Hello, good evening or good morning or whatever time it is that you're watching this. Okay, so now I'm going to talk about the formation of dative bond. In this video, I'm going to use hydroxonium ion as my example. Okay, so we know that hydroxonium ion, it is derived from water molecule. Okay, first things first, you must know what is the definition of dative bond. So I'm just going to read it out from the textbook. So they say that dative bond, or the other name for it is coordinate bond. It is a type of covalent bond where the electron pair that is shared comes from one atom only. Okay, so we know that the chemical formula for water is H₃O, right? And from this chemical formula, we can see that this hydrogen atom forms two bond with two hydrogen atoms. Okay, so we know that hydrogen atom, it is located in group 16 period 2, meaning that it has 6 valence electron, 1 2 3 4 5 6. And in order to achieve stable electron arrangement, it must need to form a type of bond with another atom. Okay, so in this case, it forms two bonds with two hydrogen atoms. And we know that hydrogen atom is located in group 1 period 1, meaning that it has one valence electron, which is one valence electron, which is equivalent to one proton. Okay. So in order for this hydrogen atom to achieve stable electron arrangement, so it must need to form a type of bond as well. So in this case, in a water molecule, one oxygen atom forms two covalent bond with two hydrogen atoms. Okay, so right now, this oxygen atom has achieved stable octet electron arrangement. Meanwhile, this hydrogen atom has achieved stable duplet electron arrangement. Okay, so now why this one is called a covalent bond is because in this sharing, this hydrogen atom contributes one electron and this hydrogen atom contributes another one electron, so that both of these atoms contribute an electron each. So therefore, they are sharing their electrons together. So therefore, this is a covalent bond. Okay, looking at this structure, we can see that now we are left with two lone pairs of electrons. Okay, now so now from this we know that a water molecule has two lone pairs of electrons. Okay, that settle for one part. Now we look at this hydrogen ion right here. Okay, so we know that hydrogen atom is located in group 1 period 1. So it has one electron, one proton. And this one electron right here, one valence electron right here, is the only electron that we have. Is the only electron that a hydrogen atom has. So now it is an ion, a positively charged ion, meaning that it has lost its only electron. So right now in this structure, we have one proton and zero electron. Okay. And now we know that in its shell, it does not have any electrons at all. Or we can say that this hydrogen ion is in electron deficient state. So in order to achieve stability, it must need to form a type of bond with another atom or another molecule. So in this case, in a hydroxonium ion, this hydrogen ion forms a dative bond with a water molecule. Okay. Now, if you were to draw the structure of a hydroxonium ion, it will look like something like this. Okay. Now we know that in this sharing, this hydrogen ion does not carry any electrons with it. So it does not contribute anything to the sharing. Meanwhile, this this oxygen atom, it carries two electrons with it, meaning that this is the thing that contributes the electrons in the sharing. So which is why this bond right here is called dative bond, because only one atom contributes electrons to the sharing. Okay, And now looking at it, this oxygen atom has achieved stable octet electron arrangement, and this hydrogen atom has achieved stable duplet electron arrangement. So meaning that this whole structure is already stable. Okay, right now, I'm going to talk about why it is positively charged. So you may have guessed or you may have not. So now I'm going to explain why. Okay, so we look at this. Initially, we look at this structure right here. Okay, so we know that an oxygen atom, it is located in group 16 period 2, meaning that it has two shells filled with electron. So the first shell carries 2 electrons in it, and the second shell carries 6 electrons in it. Okay, so in total now we have 8 electrons, which is equivalent to 8 proton. That one is for oxygen atom. And looking at hydrogen atom, it is located in group 1 period 1. So we have 1 proton and 1 electron. So in this structure, in a water molecule, we know that each of these hydrogen atoms contributes 1 electrons each. So right now we have a total of 8 plus 2, which is equivalent to 10. So we have 10 electrons, which is equivalent to 10 proton. Okay. And looking at this hydrogen ion, like I said just now, it does not carry any electrons in it. So meaning that we have 1 proton and 0 electron. So when they form a dative bond together, it will look something like this, right? Okay. Now, initially, in this part, we have 10 electrons, 10 electrons and 10 proton, plus 0 electron and 1 proton, leaving us with 10 electron and 11 proton. And we have 1 extra proton here. So therefore, this whole structure here is positively charged. And that is why this hydroxonium ion is positively charged. And I hope that it clears the doubts that you have regarding the formation of dative bond in a hydroxonium ion. And as usual, if you have any other questions, you can always hit me up on Telegram. And that will be all for this video. Bye bye.